I'm going to call this the third side. You might want to take notes on this. Third side of a triangle, okay? Okay, so what they're going to do is they're going to give you two sides of a triangle, right? So they'll tell you one side is 5 and one side is 6. What's the possible lengths for the third side? Okay? Okay. The first time I do this, I want you to visualize it, okay? So let's just say the third side is the smallest side. Could the smallest side be 1? Could the smallest side be 1? If they're whole numbers, could it be 1?
No.
Okay, there's a very logical reason why it can't be 1. Who can explain? Why can't it be
Because
1?
1 plus 5 equals 6, and that means it's literally just a straight line.
Okay, so watch this. If one side is 5, let's do that, right? So 1, 2, 3, 4, 5, right? And the other side is 1, right? 1. The longest that 5 plus 1 can go is 6. So if this point is on a swivel, right, where we're making the triangle, right, and trying to connect it, the longest that 5 and 1 can go is 6. If 5 and 1 were laid right next to each other, they would make a distance of 6. Well, that distance is 6, right? If you do it like 1, 2, 3, 4, 5, 6, right? It's not going to reach. That 1 cannot reach there, right? It can't reach it because 5 plus 1 is 6. So it cannot be, okay, so I want to make sure we understand that. It cannot be 1, right? Because 1 will not reach, because 1 plus 5 will not reach to a 6. Give me a thumbs up if that makes sense to you. Or give me a thumbs down if it doesn't make sense to you. How about that? That's better. Thumbs down if it doesn't make sense. I'll talk to you and try to help you understand it. All right. All right. So let me say it slightly different. I got some thumbs down. I got a piece that's 5, and I got a piece that's 1. Give me somebody who did thumbs down. Get on the mic real quick.
I did. I put thumbs down.
Okay. So do you get us? Do you see that I want you to picture a stick that's 5 units long and 1 unit long, right? What's the farthest? What's the farthest that a stick that's 5 units and 1 unit long can reach?
6 units.
6. So if I have a stick that's 6 units, right? I can't make a triangle because this 1 can't reach up there. And yes, I could bring it down, but it'll never touch there because where would it touch? If I had a 5 and 1, it would touch right here, right? At the end. Think about that stick that's 6 units long. If you brought it down, where would it touch? It would touch at the end of the line, right?
Yeah.
Yeah.
Which is not a triangle. Does that make sense? It's not a triangle. It would be a line, right? Because that stick of 6 would just fall flat. So these two numbers, the two smaller sides has to be bigger than the third side. If it was a 2, it would work. If this was a 2, it would work now because 5 and 2 is 7. Now this stick is a little bit longer, right? Yeah.
Yeah.
And so now it could make a triangle. Yeah. So the rule is, this is the rule. If you get this rule down, it's really the two smallest sides has to be greater than the longest side.
Isn't it like the triangle theory? Like the
It is, yeah. Triangle. It's a third angle. It's a third side theorem. I think it has different names. Yeah, third side of a triangle. All right, so let's just go through the list, and I'll walk you through them. Mics off, please, everybody. All right. Could it be 1? No, and the reason is 1 plus 5 is not greater than 6. No. Could it be 2? Yes, it could be 2 because 2 plus 5 is greater than 6. That would work. Could it be 3? Yes, because 3 plus 5 is greater than 6. I think we're getting it. Could it be 4? Yes, for the same reason. Could it be 5? Yes. Okay, so the one I want to ask about, could it be 6? Could it be 6? The answer, what do we think? Yes or no?
Yes.
Yeah, I mean, think about it. If you had a 6 and a 6, you could have a 1 going across. There's nothing stopping that. That's isosceles, right? So that would work.
Yeah.
Yes. Right? Because 6 plus 5 is greater than 6. Could it be 7? What do you guys think?
Yes.
Yep. No. No.
Well, if it was a 7 and a 1, it's a no, but yeah.
Here's the problem with 7.
If it
Now,
was a 7 and a 6 1, it would be a no, I'd say.
right? Okay, but I already have two sides. I have a 5 and a 6, right? I have a 5 and a 6 already, right?
Yeah.
Because that's the two I already started with. If I have a 7, now 7's the longest side. Oh, wait. It would work. Yeah. Because now 7's the longest side. Yeah? Now 7's the longest side, not the shortest side. So now these two add up to more than that. Could it be 8? Yes.
Yes.
Right? Because 5 plus 6 is greater than 8. So see what happens. As you figure out the numbers, at some point, the smaller one becomes the biggest one. Yeah? And there's this transition that happens. And you could just keep going. What's the first number that doesn't work? Anybody know? 11.
12.
Right. And 11 is the first number that doesn't work. Because if you have 5 and a 6 and you had an 11, then 5 plus 6 is not greater than 11. I'm going to show you a shortcut in a minute, but I want you to visualize it first. So that is not true. 5 plus 6 is not greater than 11. So 11 doesn't work. Okay? So we have a range, right? What doesn't work? 1 doesn't work, and then anything past 11 and above does not work. Okay? All right. Now, so is there a shortcut to this? Yes. I'm going to show you the shortcut. I taught this to Adam. Yeah? So we have the two sides, 5 and 6. Here's what you do. You assume that it's the smallest side first. So that's an S for smallest, okay? So then you say this. You do an algebra problem. You say the smallest side plus 5 has to be greater than 6. You do an algebra problem there. So the smallest side plus 5 has to be greater than 6. Then you do the math, minus 5 minus 5. You get the smallest side is greater than 1. Yeah? So that's what we discovered, right? It can't be 1. It has to be bigger than 1. Then what do I do again? Then I assume that the missing side is the greatest. So then I say 5 plus 6 has to be greater, and I'm going to call it G for greatest. Okay? Or let's do L for largest. Oh, L is sometimes smallest and big. How about B for biggest? Actually, I should have used L, least to greatest, right? L, I like L better. Then I can use G here. Yeah. Now the third side. So this is the thought process that happens. You first assume that the missing side is the smallest. You do the algebra. Then you assume it's the biggest and you do the algebra. So 11 is greater than G. Yeah. All right. Then I can turn this into an inequality. All right. This is what I like to do. Ready? When I write this, I like to write it where the arrow's going this way. So I'm going to switch it. If L is greater than 1, then 1 is less than L. You get it? And if L is greater than G, if 11 is greater than G, then G is less than 11. And then what I do is I bring these together. Wait. What did I do wrong? Whoa, hold on. There's something wrong. What did I do? I'm having a brain fart. Oh, okay, I'm here. Then I can bring these together. So 1 is less than the angle is less than 11. And I just did that horribly. I'm going to do it again. I'm going to do it with a different number. That probably doesn't make sense to you. All right, I'm going to dumb this down. You ready? All right, so if I had a side of 2 and I had a side of 3, what's the possible lengths for the third side? Okay, so I'm not going to call it L this time. I'm going to call it X. I should have called it X all along. So I'm going to assume X is the smallest number. So X plus the next biggest, which is 2, has to be greater than 3, right? So minus 2, we get X has to be greater than 1. And then I assume that L is the largest side, right? So I'm going to assume that it's the biggest. So what does that mean? That 2 plus 3 has to be greater than X. So then I get 5 is greater than X. Okay? X is greater than 1, but 5 is greater than X. Yeah? I like my arrows going to the left. So I'm going to rewrite this one as 1 is less than X, and X is less than 5. And then what I can do here is I can bring these together. See how they're both X there? So I can bring it together and say 1 is less than X is less than 5. Now I'll give you a shortcut. If you get 1 and 5, that's the numbers that it's between. So what you can do is you can write the X with the arrows going like this, and you can put 1 and 5. Okay, one more time. What did I do? I assumed that the missing side was the smallest. So I said x plus 2 has to be greater than 3. Then I assumed x was the biggest, which would mean 2 plus 3 has to be greater than x. All right. Let me have somebody try this when I'm talking a lot. Mike, Lauren, Megan. Megan, you've done these before, right? You're okay on this?
Yeah.
All right. Sure. Suresh, you ready? So what if the two sides were 10 and 15? Suresh, you there?
Yes, I'm here.
All right. Let's assume that it's the smallest. So what would the algebra problem say?
That x plus 10 has to be greater than 15.
Okay. So x has to be greater than what then?
5.
5. Then we assume x is the biggest. So what would the algebra problem be?
10 plus 15 is greater than x.
Good job. And then we get 25 is greater than x. Flip the inequalities around. 5 is less than x, and x is less than 25. Smash these together, and what's the inequality?
5 is less than x, which is less than 25.
That's right. That's it. Okay, thumbs up if that's making sense to you guys. Be honest. Actually, no thumbs up. Thumbs down if that's not making sense to you. Be honest. All right, Lena, I can't talk to you because of your mic. That's the problem with not having a mic. Anybody else? All right, let me have you try one. All right, what if the two sides that I already know are 10 and 20? Okay. What's the range of values for x? So x is going to be between two numbers. What two numbers is it going to be between? Hey, Adam, do you know the shortcut to these? Do you know the shortcut?
I understand what you're doing.
But can you figure out a way to quickly get these two numbers?
I know shortcut.
I don't think so.
Oh, come on. Do the problem and then look back at those two numbers and see if you can figure out what the shortcut is. Go for it.
I know shortcut.
Okay, hold on. I want Adam to do it because I don't ask him a lot of questions. Shreya, are you doing okay on this?
Yes.
All right. How'd you start it? You started it off with x plus 10 is what?
It has to be greater than 20. So that means that x has to be greater than 10. So 10 is the first one in the box. Then you assume that x is the biggest. And 10 plus 20 is greater than x. So x now has to be less than 30, and that's what's in the last box.
Okay, Adam, so look at that. 10 and 30. Look at these two numbers. Is there a way to do that shortcut? Adam, your mic's off. Come on, think about it. You have 10 and 20. What's an easy way to get 10 from 10 and 20?
20 minus 10 and 10 plus 20?
There you go. You can subtract the two numbers. That'll give you the smaller one. You can add the two numbers. That'll give you the big one. Yeah? The person who already knew how to do it, who said they knew a shortcut, was that your shortcut? I'm curious.
Yeah, that was my shortcut.
Good, Albert. Nice. See that you saw that.